Okay. So, hello everyone. My name is Rohit, and currently I am the contributor at Super Team. So, today we are gonna discuss about getting started Solana 101. And in this sequence, we are cover today how Solana work, and we are going to the elementals and some examples on Solana programs. So, let's start. Okay, so we can, yeah, we are already late. So, we can, I will share my screen. Okay. Okay, great. So I think my screen is visible. Yeah, it's visible. So let's start. So let's start. Okay, so the topic is how Solana works, presented by Rohit Goyal. It's me itself only. Okay, so to today's agenda. So what's the agenda to today? So the agenda is the Solana network. In this, we are covering technical advantage, network overview, and some Solana programs like accounts, account overview, anatomy of account, program overview, instruction and transactions, custom program data, trying it all together, and some tokens and NFTs like SPL token standard, minting and SPL token and NFTs. Okay, so let's start. So first is technical advantage. The first is fast confirmation time, low transaction fees. All were maintaining by consensus over 250 validators. Okay, so Solana transaction fees are exceptionally low. So the developer can build more robust user experience that cost loss. Solana transaction fee are exceptionally low, so developer can build robust experience. Okay, so this thing is, I don't think so. That's yeah. Solana has extremely fast block confirmation time, so user don't have wait to make sure the action worked. Solana transaction fees are exceptional development. This thing is already covered. Okay, so next is network overview. So let's take a brief look at how Solana the network creates block and process transactions. So, like most proof of stake networks, Solana elects a leader for each block creation cycle who is responsible for creating a new block. Like this is the leader and this is the validators, right? So, in this thing, we can say that let's the most of the proof of work, मतलब ये जो लीडर है इसका प्रूफ ऑफ स्टेक बहुत ज्यादा होगा जो हर एक एक वैलिडेटर को ये खुद इलेक्ट करेगा, ठीक है. So next, I think next, go ahead. Okay. Unlike Ethereum, Solana does not have a mempool. Instead, it forwards new transaction to the next leader in the block creation cycle, which means when that leader is selected, it already has all the of the transaction it need to pack into the new block. ये इथेरियम की तरह नहीं है, मतलब जैसे ट्रांजेक्शन आ रहे हैं तो लीडर के पास ऑलरेडी उन सब के क्रिएशन साइकिल के ब्लॉक्स होंगे जिससे वो न्यू ब्लॉक की तरफ ज्यादा टाइम वेस्ट ना करे बेसिकली. Okay, next Solana leverages a high throughput engine called a turbine. This disseminate information about a new block to the rest of the network. Like turbine, we have studies in previous like basis of the Solana, so you can go there for turbine. I don't want to go there again. Okay, so when a block transaction are executed, Solana runtime actually allows the operation within each transaction to run in parallel where possible the wherever the possible. The combination of these three innovation leads to greatly increase and throughput the network. Like these three validator and these three combinator are responsible for the speed of the Solana network, right? One sec, guys. Yes, previous पे जाना है. Yep. Okay. So Solana most popular innovation is proof of history, which leverages a verifiable delay function to allow all nodes in the network to agree of the passage of the time. ठीक है. So quick is a example. Like in 2002, the network slowed down during the time of the turbulence. No longer the network hummed even during massive NFT mints, like example of the Mad Lads. The significant stress event, example we can say that FTX fallout. We can see this in the average time it takes to produce a block. Rarely do we see spikes not to 4.6 seconds. As importantly, network uptime has been perfect after changing the deployment process earlier this year. Okay. So, what is the quick limits traffic leader receive from any entity? UDP with flow control. Okay, so okay, the first thing is limit traffic quick from UDP. Limit gigabytes anyone can send, but then they will create 4,000 bots. You like can understand 4,000 bots, like it's huge. Many nodes connected to the leader and sending transactions. Bots will send a large amount of data. Quick to limit traffic, like quick has to limit the traffic. Like 4,000 bots has to send to data. Like second with the connection that anyone get based on stake weight. A bot cannot connect a million civil nodes to leader. It's hard because we have already a 2k stake nodes. Leader segment stake bandwidth, unstake bandwidth, and QS is not a prioritization scheme, right? Yeah. So it means it's X by 100 you will probability. Yeah. Okay, so like yeah, this is I have said stake weight QS, like limits the connection and leader get based the stake weight and the validator. A bot cannot send a million civil nodes to a leader. This is not a prioritization scheme for transition, rather a reservation of bandwidth for stake node. We have too many nodes for attacker to saturate the network. This given network with reliance in terms of spam will provide some guarantees with that valid transaction are going through. We have the validator the way sort and drop the data. Transaction require declaration of the read and write state, allowing validator the ability to filter and prioritize. Fees only affect only other transactions utilizing the same state, which avoids the need of the global gas fee. Recently, Solana has the biggest NFT release in this year, MadLabs, and one of the biggest network migration in the history of blockchain is Helium. At the same time, and the network didn't have blip. So takeaways, like these are the highlights from the program. Fast confirmation, fast confirmation times, low transaction fees, no mempool, execute program in parallel, ideal of high performance applications. Let's see agenda. What's the happening, guys? Programming on Solana. Yeah. So now we are moving. So we have covered the Solana network technical advantage and network overview and technical advantage. We have run the fast confirmation time and low transaction fees. And in network overview, we have studied the UDP and these things. So we can move through the programming on Solana. Now let's dive into the concept. You will know when you will need to know when programming on Solana. The first thing we will want to understand is the concept of an account. An account on Solana is a slice of the data from the blockchain. Like we have a number of blockchain, so we can just separate one small block. So this block is called it account. This small block is called it account. Everything is an account, everything is everything on Solana is an account. You can kind of think it's like a computer file system where everything is a file. You can save any file on the system. This is the can call it a file. Yeah, unique 256 bit address, hold some balance of soul, can store arbitrary data storage is paid with rent. Every account has a unique address, hold some balance of soul, and current and can store arbitrary data. Based on the size of that arbitrary data, user is required to pay some value of soul. For that is called it a rent. Like if you say you have data from 1 TB to 10 TB, so then you have to pay some amount of soul. It's very very little. So yeah, since this is a blockchain data, anyone can read from an account. Also, anyone can credit sold or tokens to an account. However, only an account and an account owner can modify its data, which including debiting its soul balance. आपका सोल बैलेंस कोई भी देख सकता है, ठीक है, एंड आपके में कोई भी डेबिट कर सकता है, सॉरी क्रेडिट कर सकता है, बट नो वन कैन डेबिट फ्रॉम योर अकाउंट. लाइक इट्स ओनली द रीड ओनली प्रोग्राम, राइट? Okay, so this is the like example of from account: key number, Lamport number, data unit are 8 array. It's execute boolean. Owner, owner is a public key like which can read. If you took a look at what an actual account looks like in raw form, we can see some of the field present of account shown here like this. The key is the data type of number. Lamport's number, data unit 8 array. मतलब it's the form of the 8-bit array. Executable is boolean like true false, and owner is the public key like the key field is just account address. The Lamport is simply track that account is current balance of the soul. मतलब Lamports अपने मतलब current balance show करने में काम में आता है basically. Data, it's an RB data stored inside the account like आपके account के अंदर क्या क्या data है like if the IB data stored in the account, it's actually an executable program. The boolean is set to be true. अगर कुछ data है that's positive the user data, then it's true. Lastly, the owner field determines Solana program has authority to perform changes, this will including the balance of the lamp. Speaking of program, let's talk about the Solana programs. Smart contracts on Solana are called it the program like smart. We can make the smart contract the programs called like in C, C++, Java. We have made this. First of all, you may heard the term smart contract from the world of Ethereum. On Solana, smart contracts are called it programs. Program are a special type of account whose data is an executable program, like we mentioned before. Right now, Solana perform like Solana program can be written in Rust, C, C++, or Python. Soon we will have to write in other languages such as TypeScript and Golang, but I don't know when the time is will come. Okay, so let's move forward. Unlike Ethereum smart contracts, program don't actually have a state of their own. Instead, they perform read and write on accounts from blockchain. To perform a write, this program must be have a designated owner of the account it's attempting to modify. Program are designed to perform what are they call it instruction, and they also can send instruction to other program to the on the network, right? Programs are we can say that stateless. They read and write data to other account. The allow programs to be executed in parallel must be the owner of an account to modify. Program process instruction, program can send instruction to other programs. Yeah. Okay, so takeaways. Yeah. So what we have, everything is in account. Like firstly, we have overview of account, like सब कुछ account में है. And what is the account? Like account is a small piece of blockchain. ठीक है. All accounts hold soul. मतलब सभी accounts को soul hold करता है. Accounts can store arbitrary data. Like we can store the arbitrary data and we can read the other data and we can credit the other data, but we cannot debit. For debit we have the मतलब वी कैन डेबिट मतलब हम खुद का ये डेबिट कर सकते हैं किसी का और का तो डेबिट नहीं कर सकते या account can also store executable programs. Account are passed into the program allowing for parallel execution. So next move forwards towards uh, instruction and transactions. Program instructions. Okay, so what we have missed. Okay, so yeah, second topic we mentioned before, program are designed to process instruction. So let's dive into Solana program instructions. Like this, you can see here an instruction is displayed in raw form. These fields are mandatory in every instruction, like program ID, which should be number. Keys should be in array. The keys is different and key is different. Just note down this. Key is different, keys is different. Key is public key like your address, and keys in the form of array which store key, mutable, and signature. Mutable is in boolean, signature is in boolean, and data is unit data. Program ID is the address of the program that this instruction is going to invoke. Like program ID is like address of the your program that ये program execute होने वाला है. The keys field contain an array of all the accounts required by the instruction. You can see each accounts provide also specific whether or not this account is mutable. Is mutable is going to allow Solana runtime to make decision about parallel processing. When this instruction is sent, we will talk about signers in a minute. Lastly, the data fields hold a serialized code that tells the program which action to perform. It's also provide any required argument to the program. Okay, so like we can move forward. So how do we actually send an instruction to Solana program? So this we can say that this is a transaction, this is the RPC client, and this is the network field, right? I hope you can there. Yeah. So yeah, we have a package it up into called it it's called a transaction and send it to the RPC client, sorry, which can which then forwards to the network more on. Okay, so here's the raw transaction. You can see it's comprised of a message and array of signature. Like message, इसके अंदर instruction which in the form of the array, recent blockage which in the form of number, fee pair, public key, signature is array and unit. Inside a transaction message, we got a list of instruction. You can see transaction can send more than one instruction, and Solana runtime will allow execute them in order. In fact, Solana transaction are also atomic, which means that if any instruction fail, the entire transaction fails and no state change will occur. Like अगर अब कोई एक ही बीच की इंस्ट्रक्शन फेल हो जाती है तो पूरा ट्रांजेक्शन ब्लॉक हो जाएगा. लाइक वी कैन से कि हमने 0.5 सोल भेजे पर हमको 0.2 सोल मिले, 0.2 सोल बीच में कहीं अटक गया, ऐसा नहीं होगा, वो पूरा ट्रांजेक्शन रुक जाएगा. ठीक है. You can see we have a provider recent blockage to help validator weed out duplicate transaction. Like अगर duplicate transactions को help करने के लिए हमें blockage काम में आता है. We also have designated some account as one of the who will pay the transaction fee. The account will have to sign the transaction. That brings us to the signature section of a transaction payload. This is simply an array of this entire transaction encrypted with an account private key. The act of an encrypting something with a private key, so it can be decrypted with a public key. So it known as cryptography signing. Like हम उसे प्राइवेट कीज की तरफ से एनक्रिप्ट करते हैं जो किसी पब्लिक की के थ्रू डिक्रिप्ट की जा सकती है, एंड इस ऑल प्रोसेस किए जाते हैं क्रिप्टोग्राफी in signing. Like what is the takeaway we have studied today? We have studies till now. Programs are invoked by instruction are sent by transaction are atomic, transaction must be signed. Yeah. So let's move forward. So now we have anatomy of what are the custom program data. So like, so which are it's not topics. I don't know that. Okay, so no worries. So what about storing custom data that associate with a particular Solana program? So let's briefly revert the concept mentioned earlier about program being the designed owner of an account. Typically web2 application is able to read and write from this database whenever it's so. Okay, like it's web2 application and it's database, so we can read and write here. Okay, on Solana we have to make use of account ownership rules to leverage accounts owned by our program to store our program data. In other words, Solana program has to write to accounts that it own in order to store data on a blockchain similar to database. Like Solana program ही होगा, मतलब Solana program एक custom data मतलब आपके पास यूज डेटाबेस है तो आप पूरे में आपको जाने की जरूरत नहीं है, छोटा ब्लॉकचेन बनी हुई है उसमें एडिट कर सकते हैं. ठीक है. द मोस्ट कॉमन वे टू सेट अप ए कलेक्शन ऑफ अकाउंट्स ओन्ड बाय प्रोग्राम इज बाय यूजिंग ए सोलाना फीचर नोन एज प्रोग्राम ड्राइवर एड्रेस, मतलब पीडीए like. So okay, so a PDA address is pretty much exactly what it sounds like. Its account whose address is derived from a specific input. Basically a hash function takes an array of seeds, we call it buffer, and hashes that list it with a program address to drive a specific address. This deterministic input output method for driving addresses can be extremely useful for relating data. We will see in just a moment, like address, hash, seeds, array, and yeah. Like we can see that account, sign transaction, program. One other feature of PDA is the ability for programs to create signature for to authorize changes to an account. Consider the typical flow of authorizing changes to a standard system account. The account key is used to sign a transaction and authorize the change to its state. Now let's take a look at how PDAs do this without requiring a private key signature. As you can see this by diagram, when an account address is derived using a PDA function, it actually specifically designed so that this account can have a private key. Instead, the program uses the input seeds to create a signature from within itself and authorize changes to that account. Okay. Let's consider this example of a table of user profile information. You can see this, we are relating each record to the user wallet address. How could we represent this with a PDA accounts on Solana instead? So we can use this seeds profile plus wallet address, username and email. We could create account with the username and email instead of the data and write the seeds using a pattern like one shown. Whenever we want to look up a user profile account, all we need is their wallet address. This is a handy because in Web3 most DApp require the user to connect to wallet address, so their public key is present on the application. Now, how about this example on a table that tracks the number of posts for profile, right? Again, we can drive the seeds using the user wallet address, and now additionally their profile address, which we saw we can previously drive from only their wallet address. You can see how design this seed pattern. They can help us relate data across different types of accounts on Solana. So takeaways: account address can be derived from seeds. PDA can be used to relate data across accounts. PDA can don't have private key. The program can sign for them. So agenda, let's move towards typing it all together. Now that we have got all of the fundamental downs, let's tie it all together with an end-to-end example of a life cycle of transaction. Let's say we have a Solana program that operates on an account with this count integer field. As you can see, the only support instruction is increment function, which will increase the count by one. We start out with our decentralized application, which hosted just like a normal Web2 application. A user performs some action on our DF, and the DF sends a transaction to RPC client. Next, the RPC client routes the transaction to a validator on a Solana network. The transaction is proceed, and the instruction of our program is executed, invoking our program to perform an action. The program then modifies the state of counter account, this updating the state to one. Like this, by this whole method we can state our one, like by client, mm, then RPC, oh sorry, then RPC client, validator, program, counter, like for the value counting to one. Yeah. Takeaways: application and transaction be to an RPC client. RPC client forward transition to the network. Validator execute transaction which invoke program. Program update account state. Agenda: tokens. Now that we have to cover all the fundamental programming concept, let's talk about the token on Solana. Similar to Ethereum, Solana has a token standard for any new tokens on its network, called it SPL token standard. However, this standard operates slightly different. The biggest difference is that Solana actually uses native program deploy natively to the chain to manage the creation of the new token. These program enforce adherence on the SPL token standard, but they also give users the ability to create token without having to write their own program. A token on Solana is represented by an account called a mint. This account has the core information about an SPL token mint. As you can see, there are a handful of other accounts that relate to the mint account, which facilitate certain action or properties for that token. To track a wallet balance of any mint, we use an account called it associate token account, which, as you can see, relates to both the mint and the wallet. More on this later. For any associated metadata for a mint, such as images, title, etc., we leverage one or more metadata accounts which are created by metadata program. Metadata program is not a native Solana program, but it does play a role in the metadata standard. The key here is that unlike other chains like Ethereum, we don't need to deploy any program or smart contract to create a new token. We can do this completely off chain by sending instruction to existing program and requesting a new token to be created. Takeaways: you don't have to deploy program to create a new token. You can create new token using RPC, using only RPC call. Relate accounts are used to describe tokens. Agenda. All right, so let's tie it all together to see how token work on Solana. Here's the walkthrough of the process of creating a new NFT and minting it to the user wallet. First, we create a new account that will be our mint account. Next, we initialize that account as a mint by adding the required data we see previously. We can create any metadata account like metadata master edition, etc. Now we need a wallet to mint this token to. Then we create an associate token for the user wallet so we can store the balance of this new mint for their wallet. And finally, we use the token program to mint a new token to this user associate token account. All of these steps are done by sending instruction to respected program for each type of an account. Let's take okay. So let's create a custom joy token. Like this is the image I have took randomly. Okay, create a new mint. Create a new account for the mint. Initialize the account as a mint. Initialize, give our token an icon by using metadata. Now our token is all to set up. Nikhil's wallet, John's wallet, create associate token accounts, mint then some tokens. Yep. So we have to create new account, initialize that account. Oh, sorry. Initialize that account to a mint, give a token icon by metadata, matlab link to the metadata. Now is a matlab joy token is ready. Now we have Nikhil wallet and John's wallet. Create a associate token account, mint them. So we have this thing, right? So yeah, takeaways. A mint must be created. Sorry, a mint must be created and initialized before it can be minted to someone. An associate token account is required to mint someone's wallet. Token 22 introduce a brand new feature of SPL tokens. So now let's talk about NFT. Speaking of metadata, let's talk about NFTs. Again, NFT have zero decimal place and have ability to mint new tokens. Disable after one. The metadata standard on Solana it use countless ways to customize NFT and the user experience. SPL tokens have zero. Like, yeah. For example, an NFT could be a master edition, which means NFT can serve as a single unique master copy while allowing for print versions to create a based on it. It could be also belong to a collection which has its own metadata. Takeaways: NFT has zero decimal places and a supply of one. NFT metadata is highly customizable. Agenda. Now let that we have covered all of the fundamental programming concept. Let's talk about the token on Solana. Let's break down the mint account that this token represent the token itself and store some data about the token. There is only one of this token for any SPL token. You can see we got a boolean for whether or not this mint has been initialized and the total supply. The decimal field actually determines how you supply is fractionalized. For example, if one set a decimal to 3 and I want to send one token, I am actually sending a 0.001. This is because SPL token actually have a maximum supply. So you can leverage decimal to manage your supply. When it's come to NFT, the decimal value is 0. That because one NFT is simply one token. The mint authority is the account that allows to introduce new tokens to the total supply, called it minting. This account must sign in any transaction that mint a new token for this mint. The freeze authority is the account that allowed to freeze movement of token for a particular associate token account. This means that token will not be allowed to move into or out of that account. Again, freezing a token required this account signature. This brings us to associate token account. As you can see, this account are used to represent and account balance of certain SPL token. We leverage seeds to drive address of an associate token account, like we saw in the PD example earlier. This pattern for driving an associate token accounts address is part of the SPL token standard. Like associate token account, metadata accounts also drive their address from a standard seed pattern. However, this pattern is actually separate from the SPL token standard. And instead of follow the SPL token metadata standard, these standards are separate because the metadata program is not a native Solana program, but instead was created a community project. Takeaways: so mint accounts house data about a mint. Associate token accounts store a user balance for a particular mint. Metadata store, yeah. So let's dive into the concept. Okay, so yeah. Thank you, everyone. So, firstly, I can revise all of the thing. I know I have pretty fast this time. I have pretty fast. So, yeah. Let's taking first. Yeah, yeah. Wait a second. Yeah. I guess I am, yeah. I guess I am on, I guess I am on first. Yeah. So, what's the total agenda? Yeah. So, the what's the agenda, right? So, so what's the agenda? Like Solana network. In this, we have studied today the technical advantage, network overview. Let's move toward the Solana programming models, account overview, anatomy of an account, programs overview, anatomy of instruction, anatomy of transaction, data ownership, program address, PDA, like we can life cycle of transaction. Then we have some example of token and NFT like SQL token standard and their overview and token program, step to mint token and NFT overview, right? So technical advantage, the first is fast confirmation time and low transaction fees. Okay, and network overview, we have the proof of stake is the leader and all other is validator. And unlike Ethereum, the Solana does not use a mempool. Solana leverages a high throughput engine called a turbine. This maintains when a block transaction are executed, Solana runtime actually allows the operation actually allows the operation within each transaction to run in parallel wherever possible. The combination of these three innovation leads to greatly increase by speed throughout the network. Solana most popular innovation is POH, like proof of history, which leverages the VDF, verifiable delay function. In 2002, we have the quick example of NFT mints like MATLAB and FTX live for Fallout. This limits the traffic leader received from any entity, UDP data flow control. This is not a prioritized scheme. This is not a prioritized scheme. One second. This is not a prioritization. This is not a prioritization scheme for transaction. Rather, reservation of bandwidth for stake nodes. We have too many nodes for attackers to saturate network. This give us network wise reliance in terms of spam. Required transition required declaration. One second. Yeah. So let's move. Transaction require declaration of read and write state, allowing validator the ability to filter and prioritize. Fees only affect other transactions utilizing the same state, which avoids the need of the global gas fee. So, what are the takeaways till now? These are the Solana networks. Fast transaction times, low transaction fees, no mempool, execute program in parallel. So, let's move toward the accounts. Accounts, everything is an account. Unique 256-bit address holds some balance of soul, can store RB data, data storage paid with rent. Anyone can get it, soul or read data. Only the account owner can debit or modify the date. This is a raw form, the actual account. The key field is the account address. Lamports, it's the current, sorry, current balance of the soul. Data is the RB data, which is stored inside of an account. If the RB data is stored in this account is actually an executable program, it's execute boolean which said to be true. Lastly, the owner field determine the Solana program and authority to perform changes to its account data, including the balance of the lamp ports. Speaking of program, yeah, first of all, you must have defined the Ethereum smart contract from Ethereum. On Solana we can call it program. Solana programs can run into Rust, C++ on Python. Unlike Ethereum smart contract that does not have actually state of their own. Instead, they perform read and write on account from the blockchain. To perform write, the program must be the designated owner of the account it's attempting to modify. That is called it the instruction, right? Let's take away. Take away is everything as account, all accounts sold. And accounts can store arbitrary data. Accounts can store executable program. We mentioned programmed instruction, so let's dive into programmed instruction. You can see here instruction is in draw form. Program ID is the address of the program that instruction is going to invoke. The key field contains array of an all required by instruction. Lastly, the data below the serialized codes and tells the program which action to perform. It's also provide any required argument to the program. So let's talk about the takeaways. Program are invoked by instruction. Instruction are sent by transition. Transition are atomic. Transition must be signed, right? Okay. So ownership. Ownership. Let's not went there. Let's talk about the takeaway. Account address can be derived from seeds. PDA can be used to relate data across accounts. PDA doesn't have private key and programs. So let's talk about the takeaway in the RPC cloud. Application and transaction to an RPC cloud. RPC client towards transaction to the network. Validator execute transaction which invoke the program. Program update account state tag. Yeah. So let's move towards the takeaway of Mint Vola. You don't have to deploy a program to create a new token. You can create new token using RPC calls. Relate account are used to be the dislocate tokens. Yeah. Yes. So this example of joy. So yeah, yes. Okay. So thank you guys. Like if you have any question, you can drop in the comment section. I will them. Okay. So bye bye everyone. Bye.